Go ahead.
All right, for those of you in Maryland, a one-party state. Uh, the so thanks for having me here. You're talking about the secure element, which has started in iOS and has propagated everywhere. My name is Mark Anderson, and I'm an iOS engineer at Fundrise. We're a real estate investment company. You may have heard our ads. You want to check out our app and see some of my fine handiwork, feel free. That's really kind of move us into who I am if you don't know already. I'm currently working on our iOS apps for Fundrise. I built chips with IBM for 6 years and iOS apps at Capital One for 7. I have a little ones and twos in there during the startup era. And I did even do some work as a process engineer. So I've even built transistors with my bare hands. So I have a weird resume, but it kind of makes this sort of a very interesting topic to maybe for a number of reasons. If you look, we start with, I just want to say that do not use any of the code that I show in production in any form. Don't try. Don't, like, I can't stress it enough, because if you try to do cryptography on your own without knowing what you're doing, you will mess it up, and then everyone will get your data. Especially in some of the code I'm going to show, I have some bad practices, which I mark up. But one of the best ways to handle just writing data, just like I'm showing here, if you do complete file protection, it actually uses the secure element to encrypt. So this is all just kind of fun side things. There are a lot of, and towards the end, I'll talk about some extra things that we can do with the secure element that are kind of cool. So, okay, so what is the secure enclave? Now, it's in a bunch of places we'll see on another slide. But what it is on iOS devices, it's a dedicated ARM core called the Kingfisher, running about 300 megahertz, 400 megahertz, something like that. No one knows for sure because there's not a lot of information. This is from a black hat, sort of reversing. And some of it, it exists outside of the regular realm of control. It has a cryptography engine in it. It has a true random number generator. It has a pseudo random number generator. It has a UUID, and it has a lot of dedicated input output, every kind of thing that you would ever ask for. One of the interesting bits really about this is on current Macs, well, on all iPhones and on current Macs, they connect all of the flash through this chip, which is the secure enclave is on the T2 chip on a Mac, and it's just on the regular, A12 or whatever on an iPhone. And all of the flash goes through that. So everything is encrypted all the time on that flash. So if you go in, you'll notice on a new Mac, if you buy a new Mac and you hit use file vault, it just works. It like nothing happens. It was so quick, I thought it didn't actually do anything. But it turns out that they're always encrypting stuff on the drives. And all you do when you hit that file vault thing is you're password protecting it, which is a kind of an interesting thing that they've decided to do. I think it's probably, if I had to guess, it's just kind of the easiest thing to do, and probably the most privacy protecting. But you can never tell with Apple. So what this happens is there was once a recovery port. If you took the back off, you'd actually plug in a special Mac dongle and you could take your data off. But this is how we get the importance of backups. If that L2 chip on your Mac dies, which has a secure enclave, your data is lost forever. It has to be running to be able to decrypt the data. You need it runs, for those of you who are interested, it runs an L4 kernel, which is this real-time microkernel. They call it the secure element OS. I think it must be the secure, I forget what the SEP OS is, secure element something OS. Like I said, this is all cool and I love it. I was actually looking for, I have one, I've seen some in the past. I was looking for a micrograph to show you what it looks like. But there, once again, it's hard to find something without paying money. I could have gotten an X-ray, but I would have had to pay a fair amount of money for it. And so this is basically this is what I was talking about. Like, this is sort of the high level view of it. And you really don't have to go into all this, but the basic idea is that inside they have a fair amount of keys that are inaccessible, and then you're password protecting them. So the keys are only also as good as your password, right? Or your Touch ID. So if you have a really lousy password on your Mac, it doesn't really matter how powerful the secure enclave is, because it's not going to do anything. Or on iOS, like, so if you have like if you have 1, 2, 3, 4, 5, the Spaceballs code for your iOS device, it's also not going to be super secure, because it uses the passcode in the case of iOS. So this is just sort of an advertisement for good passwords, and sort of a bit of a the highest level thing that we can see. So where is it? Okay, so if any kind of T1 chip or T2 chip in your computer, any of the Apple TVs that you can program, any Apple Watch except for the very, very first one that they want us all to forget about has it. Because Apple Pay wasn't available. So anything 5S or later. So a good rule of thumb, if you're looking for it to play with it, is if your device has Touch ID or Apple Pay or Face ID or something like that, it'll have this on it. On the iPhones and iPads, it's contained on the actual, just what they would call the application processor. In the regular, on the Macs, it's in the T1 and the T2, which is sort of a bridge chip that they were using to drive Touch ID and the Touch Bar and all that fancy stuff. It's also in the HomePod, which I was very surprised about. I don't know what it does in the HomePod. If anyone can you use Apple Pay on the HomePod? Maybe it's because Siri's on there, but it was just sort of an interesting tidbit. All right, so what do we really care about? This is the bit that we really care about, is it creates 256-bit private elliptic curve keys. So you're locked in to your algorithm. It's a good algorithm, so it's not such a bad thing. But if you're doing something where you need a particular algorithm, you're kind of out of luck. It can only generate keys, right? Generate and load its own keys. It can't load keys from the outside. It can't tell you what its keys are. And that's considered a feature. It is a feature. The idea is, unless somebody's really going at this, your encryption keys are safe. And if you read some of one of the things I have linked here, and I can share the links with the presentation with everyone. If you look at, when Black Hat and everything tried to take it apart, I mean, it is very, it's very heavily protected. It's, every angle you could think of, they're trying to patch up where you can't get to it from the application processor. You can't try to undo it and try to attack it via a debugging interface called JTAG. You can't, it is hard to get in there to get these keys out there. And part of it is there's a key, some keys and IDs that are what we call fused in, which is, on the assembly line, you get a key assigned, a key is generated, and then it gets permanently burnt in, using fuses that on the chip. So there are some permanent things that can't be undone, which is once again another reason why if you use this as a method and you don't back up your data and you forget your key, or the T2 dies, or the application, or your iPhone dies, you're just kind of out of luck. The nice bit is that from a programming perspective, you can just forget everything I just said. I mean, I don't think you should forget everything I just said, but if you're looking to program it, it's basically like a magic box. You say, hey, secure enclave, encrypt this for me, generate a key for me. And it says, okay. And say, hey, encrypt this. Okay. Hey, sign this. Okay. And you don't have to do anything in the interim. And all of it is accelerated, even though it's running a lot slower than the chip itself and things like that. It's way faster than you could probably get on your even on your Intel CPU, even unless you were doing something that isn't designed for it, which is to say, trying to break passwords. So, and this is again what I said when I talked about, if I got a pointer here, this bit here is what I was talking about before. You have the Intel chip talking to the T2 chip, which has the secure enclave in it, and this is a little misleading because the secure enclave includes the crypto engine as well, and it talks to the solid state, which is the key reason that you need it back. So before CryptoKit, and I'm being slightly unfair here because I'm using security, which I don't in some of the Swift. But in order to create the random key, we had to drop down a lot of C. I don't know who's used the security framework. This is what this is all from. It's a lot more intimidating than it seems. It's mainly because it's C and Objective-C kind of in a mix here, is why it's kind of lousy here. If you look, right, you just this is and this we can do in the other ones, but you're not required to. You're basically saying when you unlock the device, the person can use the things, and then the big thing here is this one here with a token ID. You're telling it to create it on the secure enclave, and then you're creating a random key. And you're using this CF dictionary ref, and there's pointers, and you have to use bridging releases. And don't use this unless you really know what you're doing. Actually, don't use any of it unless you really know what you're doing. But in particular, this is a particularly grody way to connect to it. There's still a bit of it you'll have to deal with, which is why I left it out in some of the later slides. Is if you take the access control stuff, that's still in the security framework, which is still in kind of an unswifty bit. They do clean it up a little bit, but that's where you're at. I don't know if I see, there's some more here. Well, and now with CryptoKit. Coming up, then there's a new framework, mostly, I believe entirely Swift, but mostly Swift, where you can now interact with the secure enclave in particular, more easily. Now, with everything more easily when it comes to cryptography, but now with the secure element, it's much, much easier. So here's the first one, a first example of what we're dealing with, right? So we create a private key. Now this is a signing key, and you'll see sort of the difference in a bit. And you get, if you put this in I try to make this so that you can copy and paste these into a playground and it'll run. So a lot of this is copied straight out of the playground. So you see here, it spits out, and this is what you get. You get a signing key out and some sort of, I don't know my large number theory, so I don't know what all this stuff is about the public key. But as you can see, it does spit it out, and then it spits out sort of a representation of the private key. Now moving on, you can create data representation. So this is what you would typically save into the keychain or on disk. I just printed it out because it's kind of nice. But if you need to save this anywhere, this is the format you use, and it's, as you would say, it's like, wait a minute, did you say you can't get the key out? Because that sure as hell looks like a key. And if we go back one, it is. I mean, if I put this in 64, I don't know how many of you know, formats. If I cut this off at 64 characters and put a little thing around it, it would look an awful lot like a key. So it does look like a key, but it's not really. You feed this key to the secure enclave, and then it decrypts your data. And if you can take this key and try to run it, like if you take this key and try to run it on another secure enclave, it will fail to decrypt your data. If you try to run it through the algorithm that you're expecting, it will also fail to decrypt your data. So once again, I am hammering the point that things are stuck on your phone or on your thing. It sort of underlies one of the major sort of reasons that it's difficult to steal data off of Apple devices. So we have a key pair we can encrypt. So this is what I'm doing here is as you can see, my code is shouting. So first off, don't do that. I'm force unwrapping a lot of things. But this, you should be able to paste this right into a playground, and I can show that if we've got a little bit of time. And this seems extremely complicated, but what we're really doing is the secure element is set up to do signing and public-private things. So if you look at the examples of one of the things, they'll show like, Alice and Bob, and then doing the public-private key bit. But because of that, we can, since we do have public and private key, we can just do symmetric encryption by sort of signing everything with our public key and our private key, and you get a symmetric key. And so it's pretty much as easy as if secure enclave is available, which is kind of great. These are all enums. I created a salt that is horrifying. Don't use this salt if you're gonna go through. You need to understand what a salt is and how to do it. But this will work. It just needs to be some data. And then you can grab the private key out of the secure enclave. Now the private key is, you're not really grabbing it out, obviously, but you're getting the pointer to it. And from that, you can use, I don't know if I can't see this, but everyone else can here, hopefully, yeah. If you have over here, it shows the private key. So what I'm doing is basically just creating a shared secret with my current private key and my public key, which is creating a symmetric encryption. And to create one, then you have to take the shared secret and then create an HKDF, or there's a various number of functions that you can use, which once again, I'm going to, beyond the scope of this course, but there are a number of ways that you can handle it. And the same goes for, it needs a hash, which once again, you can do a whole bunch more than just SHA-256. Protocol, the salt, shared info, blank, which in this case works. I wouldn't necessarily do that in person either. And then you just take data, which is regular old data, and I would suspect it'd be worse than, bigger than hello world. But then you just take this, AES, GCM mode, which again is just a mode on AES. And then you can basically seal what they call like a box. And so you use the seal command and you just feed it your symmetric key and some data, and you've locked your encrypted data. And then to unlock it, you have the encrypted data, you feed it the encrypted data, and you get the symmetric with the symmetric key, and you can undo it. The big and the reason that these prints that I'm not showing them is once again, I want you to be able to copy this right out of here into a playground and do it. Apple also has a playground that I would recommend, although it's a little bit, it doesn't deal with the secure enclave at all, and it is a little more like higher level. So if you're just interested in seeing stuff work, this is a good start. And so here are the resources. So what I would like to do, if we, and I think we've got plenty of time. What I'd like to do is change sharing. Let's see. And so, all right. Come on, new share, here we go. All right, so here's the playground.
I think, no, we got it. Okay, cool.
Yeah, I just took me a while. So this is the same code, right? And just to prove that I'm not lying to you, we can go through and run this. And I don't know if it just decided because it hasn't changed, it's not going to run again, or ready to continue crypto. So yeah, so it ran it. Okay, and there you go. So this is the ciphertext I showed in a base 64 encoded string, and then that's hello world. If you look on the side, you see this key agreement business. You have a shared secret, and a lot of this stuff you can print something out, but you won't get necessarily, you won't get the actual key. The other bit is what I showed here, and this actually goes a little further than in the slides. We create, instead of doing, when you want to do symmetric encryption, you're using this key agreement, or symmetric or asymmetric encryption. You need to use key agreement. In this case, if we're doing signing, we can use the signing private key. You create, this is the data representation of the key, which also looks like a key, but is not like, it is a key. I think it is a key. I think you can actually encrypt with it, but it doesn't correspond to the actual key that's doing anything. So that's one of the interesting bits. And then here we're just signing hello world, and I don't know how to do HMAC or whatever in my head, so I'm going to just trust that that's correct. But this is where we are with that. So that's the long and short of it. It's with CryptoKit now. It's super easy. Like if you've been using anything with the secure framework, I would totally look at ditching it, because this is not only just for the secure enclave. If you want to use CryptoKit for other things, and I'm sure somebody could give probably a semester-long course on CryptoKit. You can use you don't have to be fancy to use a secure enclave. You can use just your regular old encryption. And there are a lot of neat things coming out about it with this. They have a few where you can do SSH. You do SSH signing. So basically what happens is you go up and it pings. The key exchange for SSH is done through the secure enclave. And then, so you don't actually have to, the keys can reside somewhere else. There's a few of those. And so people are doing some interesting things where you're using the ability to either sign or do basic, Diffie-Hellman key exchange or any of the things that any of the algorithms the secure enclave allows to do sort of off the wall things. And that's kind of why the only reason you would do any of this stuff, right? I mean, if you're just trying to encrypt files, you don't really have to go in and do this. I mean, it's more along the lines if you're trying to do some sort of neat new product, you do this. But you can also, like with these keys, if you don't want to put things in the keychain, and I don't know why you wouldn't want to put things in the keychain, you can also write these keys as flat files and then bring them back in. You can do, I mean, these, for all intents and purposes, as long as you're running on the same secure enclave, you can use the outputs that you get. And of course, one of the things you can do is this private key takes, if I remember correctly, takes access control. So if you have, and I didn't want to go into this again, once again, beyond the scope of our talk, but what you can do is take, all that, unfortunately, still in the security framework junk from the secure access control, and make it so that the device has to be unlocked, and you have to use the device password rather than because everything I've shown up till now is completely not password protected, right? Which is another reason, don't try this at home without reading some more out of it. So, and I will try to make sure that I get you guys this stuff so that you can make it available for people to play with. But other than that, that's what I've got. If anyone has any questions, I'm more than happy to take them at this time.
Yeah, if anyone has questions and would like to do it over the mic, feel free to click on the yes button on your Zoom, and then we can we'll unmute you and let you ask your question. All right, Jay.
Hey, it's really interesting. Thanks. I've actually seen some of the keychain stuff with the secure enclave, but I've never used it just for encryption like this. I was wondering if you knew that data representation. If I have that, if I generate a key, I grab the data representation and then reset the device and try to import a key using that data representation. Do you know if that'll work?
It should, because my understanding, and don't talk to Apple about this in terms of whether or not this is absolutely true, but my understanding is there is some sort of key on the device, and then they're taking a key and then encrypting a key and doing some magic. So it really is, it's very heavily tied to whatever the fuses are set on the T2. So you should be okay.
So it's unique to the device, but not not erased when you reset it.
Not erased when you reset it, which is how the keychain can go between things. Now, I haven't tried it, but that's actually kind of, and now that you mentioned it, I kind of want to give it a try and see if it works. But yeah, it's definitely you don't reset the secure enclave. Pretty much nothing can get in or out, right? So I think there may be a way, you'll have to ask your Black Hat pals or whatever to actually have it clear all of its keys, but I don't think that's there may be if it full factory reset, maybe they do for that reason. I'll have to look at it. I'll have to get back to you on that, because now that I think about it.
Yeah, just curious.
Yeah, now that I think about it, because I just thought of a vector of attack, and so now I'm wondering.
You could use it to maybe track devices across resets.
Yeah, you could, right? Yeah, and there's a bunch of stuff. Yeah, so part of me thinks they may clear them, but there's no technical reason.
Fun to try.
Yeah, there's no technical reason for sure. It's jumping between devices that is just completely impossible.
Thanks, Jay. Let's see. Are there any other questions? And while we keep an eye out for other questions, I'm just going to add our feedback link into the chat one more time. So if you guys can just give us some feedback. on the meetup itself, and then any feedback you can give to Mark as well, we'll forward that to him as well. And then another link that I'll add is on top of that is our channel for these videos. That's where these videos will be posted if you guys want to watch this again later.
Cool. Is that on? Is that YouTube?
Yep.
Yeah, I'll be on
I haven't seen it
our
yet.
DC Dev community channel.
Cool.
Yep,
Yeah.
and that's where we'll post all of our DC iOS, our DC Flutter, DC Androids, all our meetups kind of posted in the same spot. It's easy to find.
Cool. Yeah, and I will definitely. Should I? Who should I send the the decks and stuff to so you can?
Either me or
What was
either
that?
me-
Okay. Who's the me again? I didn't see that. Who was
Scott. So either Scott or Joseph.
Scott? There we go. Yeah, I'm trying to see whose microphones are moving, but a lot of people in here.
Cool. Well, if we don't have anything else, some other dates to keep in mind. We'll have another DC iOS meetup, probably most likely virtual again, June 9th. I know Victor is planning a presentation for us. Victor is here in this meetup with us right now. So we'll hear from him what he ends up planning to choose to do a talk on.
He's raising his hand. Let's unmute. Oh, someone beat me to it.
Yep. So then, other than that, we have WWDC happening June 22nd, and that'll be virtual as well. So looking forward to what will come out of that. And actually, the following meetup on July 2nd. So we're second Tuesday every month, but in July we'll probably do an open group discussion on some of the new stuff that came out for WWDC, and we have a speaker set up for July as well.
Hey, sorry. Hey, Victor, I unmuted you because you had your hand up, or it looked like you did.
I was just saying hi because Lucy was saying.
Oh yeah. It's good to see a lot of names, if not faces of people. I'm a little bummed I didn't get to see everybody in person.
And I think we got some other questions coming in. So one coming in from Craig. Is there a maximum number of keys that can be stored per app or overall?
It isn't so much the number of keys. Like there's really just like a master key, and then you can. So there isn't one. No, everyone will have their own. It'll generate keys, and then, they're all based on the T2's master key generating function. So.
It looked like Steve had a question.
Yeah, I already muted Steve.
Hey, Steve, what's up? Steve?
What's that?
Oh,
Let me unmute him.
Yep. Yeah, unmute him.
Okay, can you hear me now?
Yep, we can hear you now.
Thanks for the talk. When you post the YouTube videos, please post the source code. You said you had some playground.
Oh yeah, absolutely. Yeah, the
Okay.
playground. I definitely want to make sure that, like I said, both this playground and if you take the code from those slides, I made sure that I took and copied and pasted them from the playgrounds. So if if this playground ever gets lost or whatever, you can actually just copy directly from the slides.
That's not my question. My question is, we don't know the exact format that Apple's going to do for WWDC. If they have a keynote again, or at least a first day announcements, would anyone else be interested in doing a group Zoom so that we could be together talking about it while the announcements is going on? I would be interested, even if it's just nothing but the chat room, but even it might be an idea for us to organize.
I'm on board.
We actually were going to bring that up in discussion. So keep an eye out. If that happens, we will definitely make everyone know. We'll send up a note to the meetup and set up a event for once we exactly figure out more what DubDub's format's going to be.
Thank you. That's it.
Yeah, I think that's a great idea. Definitely something we'll try to get together, and then it'll probably be through the meetup again. So just keep an eye out. Also, we have our Twitter. If you guys are following on there, it is DC_iOS. I can post that handle for you. So if you are on there, you can keep an eye out what we have coming out. Is there anything else, Scott, that I'm missing?
No, I think that's it. Just keep an eye out, and then yeah, I guess for when we get the source code, we'll probably just send that out as an email to everyone who are RSVP'd through the meetup.
Yeah.
Those of us who are just responded through the other channel, just message one of us, and we'll make sure it gets out.
And how do you want the slides? Like, I mean, it's a Google thing. I can send it PDF if you like, or.
Yeah, you can. So Mark, we'll get back to you on that one because I guess we'd have to figure out where to put the slides actually. So that's
Okay. Otherwise, I have my I've got my email on there for my work email, and I can I can, if anyone's interested, like super interested, and I know there's a lot of people on here who will even know my personal email. So either way.
Yeah, Mark, we can talk with you about that. So when we post that to the YouTube, we can, if you choose, you can have it on there,
Oh,
or
cool.
just email the people that attended today if they use their email to come in. But other than that, we're also on the Cocoa Heads like Slack.
Oh, I didn't even know about that. Yeah, if you could send me the information about that, that's cool.
Yeah, so I'll add you into that as well. So that's a large nationwide Slack channel for all Cocoa Heads. And actually, we got some guys coming in from all over the place. Jay being one of them. I think Jay, correct me if I'm wrong. You're Atlanta or Georgia, somewhere right there, right?
Not me. No, I'm here in the DC area.
Oh, all right. For some reason, I thought you were down from Atlanta. Okay, so
I was gonna be like, wait, what happened, Jay? Is there? Boy, am I not checked in enough?
maybe I'm thinking of Jeff then. So, but yeah, I definitely see some guys coming in from Cocoa Heads. So that's awesome. We're getting communities and groups of people from outside of the DC area now that we're virtual. So
yeah, that's very cool. Yeah, thanks for having me. Like I said, I'm a little bummed I can't see you in person, but I'll be sure to come to one and or give another talk because I actually promised Caitlin, who I work with, she was going to embarrass me with all sorts of stuff. So I have to make sure to have an in-person talk so that she can do it.
gotcha. Yeah, so it looks like down here. So sorry, Jay, I got you mixed up. I know Jeff's coming in from Chicago. We got Edward from Boston, and Bob also from Chicago was on here just a little beforehand. And actually, they are about to start their Chicago Cocoa Heads. They started about 10 minutes ago. So if that is something that interests you, that or like it's too late. Okay, I was gonna say.
Yeah, try it.
I was just saying it's too late to.
Yeah. I'm generally.
Oh, that's right. Bob reminded me about time zones. I always have an issue with those, not just when
Oh
programming.
yeah. That's why I think I let Chad do that talk, but there's a whole talk about just let the computer do it.
Right.
All right. Cool.
Let me see if I can find that link for the Chicago one, and I can post that in here. Or Bob, since you're on here, you want to just post that link for anyone looking to switch over to the Chicago meetup later? Awesome. So he should have that up in a minute if anyone's looking to switch over to Chicago. I know I volunteered to go to Greenville, South Carolina, Cocoa Heads right after this one. So it's I'm hopping all over the country.
Oh, WebEx, man. That's
There you go.
all right.
Cool. Thanks, Bob.
I'll finish up my using Meet, Zoom, and WebEx in one day. I don't know. Cool. Well, thanks everybody for putting up with me for however long it was. And if you have any questions, I'm very shy, so feel free to reach out.
And Mark, do you have a Twitter or anything where people can follow?
I do. It's at Mark EMER.
Could you add that to the chat down here too, just so people can copy and paste it?
Yeah, I actually was going to put it on my opening slide, and I totally forgot.
All right. So I'm happy I reminded you that. I know we definitely want to be able to ask you questions on later because this stuff is definitely complicated.
And one thing I actually should warn everyone before we go, the documentation is not good. So for CryptoKit and things like that. So yeah, it'll be a learning experience for all of us.
Sure. Great.
All right, great.
Thanks, everyone. Reminder again, please fill out our feedback form. We love to hear from you guys. And we're trying to improve DCIs as much as we can. And keep an eye out for the WWDC kind of group watch when that comes up, and for our next meetup in June 9th. Thanks, everyone.
Thanks again.
Thank you, everyone.